Hi, this is Dr. Brandon Schamp from Algoma University, and today I'm going to give a brief explanation on how to take some data from a spreadsheet, Microsoft Excel, and put it in SPSS, a statistical program, and run an ANOVA, or an Analysis of Variance, which is a statistical test used to test for differences between treatments or different groupings of data. In this case, my sample data is species richness data, or the number of species found in different plots in low disturbance communities, medium disturbance communities, and high disturbance communities. So what my ANOVA is going to test is whether species richness is higher in or lower, significantly so, in one or more of these pairings of communities, low versus medium, low versus high, etc. Now, before we get to SPSS, I have to change the formatting of the data so it's convenient to do this test. So what I've done is I've copied all of the species richness data from these three columns into a single column here, and I have a treatment column beside it. So 1 in this treatment column here represents low disturbance, and if you go down after 20 data points, we get to 2, which is the medium disturbance, and 3, which is the high disturbance. So that's altogether, there were 20 samples from each of the three communities. There's 60 different samples here. And you can display it in 2 columns in this way. So I'm going to copy these summary data. Notice I did that without copying the titles. And then I'm going to call up SPSS. And now SPSS, you'll have to choose at the front end, before this screen opens actually, to write in data. But once you get to here, you'll see it's a lot like a spreadsheet, and that's by design. So what I'm going to do under Data View, so there's 2 different views here, is I'm going to select the first cell and paste my data in. Now the data are in there, but I want to add some titles and make sure the data or the program understands what kind of data each of these columns represents before I proceed. So I go to Variable View, and then selecting each variable, I can type in something that's representative. So in this case, I'm going to type in dist treatment for disturbance treatment. Notice I didn't use any spaces. That's the way SPSS likes it. And for the second one, SP richness, and that'll remind me what those are. It's up to you to choose designations that are going to be clear to you later on. And then I'm going to go over and select measure to identify what kind of data each of these are. So the disturbance treatment data, the 1, 2, 3, each of those represents a category of community. And so the category selection is nominal. All right, so I choose nominal so that it recognizes 1, 2, and 3 as those 3 categories. Now for species richness, I'm just going to select scale data. It's continuous numeric data, and that's the way I want it. So then I return to data view, and I go up to Analyze. Oh, before I do that, I want to mention one other thing. Usually before you conduct an ANOVA, you have to check whether your data conform to the expectation that they represent a sample from a somewhat normal distribution. That's an important component of the test. I'm not going to do that right now for a couple of reasons, although I do have another video that you can explore that teaches you how to do that in SPSS. But instead, rest assured, the data here are normal. One of the reasons I don't want to do it is because I would have to do it for each treatment individually, and the way I have the data structured here, it's a little harder to do that. Okay, so once I have this, I can continue to the ANOVA under Analyze, Compare Means, and One-Way ANOVA. And it's fairly simple from there. You choose the dependent variable, which you want to know about whether it's different across the treatments, and you put that in the dependent list. And your treatments or your factors go into factor. Now you can run it for here, and that just gives you a single test that tells you whether there are significant differences among the treatments. Now that's useful information, but it doesn't tell you between which treatments. So one thing that you can do is select a post-hoc test from up here. Okay, and what that's designed to do is to follow the ANOVA with an additional test that seeks to test specific differences between the treatments, so between each pair of treatments, if you will. So in our case, it would be testing between low and medium disturbance, low and high disturbance, and medium and high disturbance. Those are the 3 combinations possible. Now, there are a lot of different tests that you can choose here. I'm going to choose this one, not because I prefer it to any of these or because I'm advocating on it. It's just a simple choice to make. It's a common test that you can apply. And then I'll just simply continue. Now the results of this test are first an ANOVA table, and there's lots of information here, but most of you are going to be predominantly interested in this value over here, the significance or the p-value. And if that's lower than 0.05, excuse me, then that means that there are significant differences in species richness between the low, medium, and high disturbance communities. All right. Now, which are different? Well, to find that out, you go to your post-hoc test or your multiple comparison Tukey HSD test here, and you can see that it compares different pairs. So different treatments, disturbance, low disturbance versus medium disturbance, significantly different. Low versus high, not significantly different. And you can continue down here, medium disturbance versus low, significant difference. That's the same as this one up here. Medium versus high, significant difference. And then these last ones are actually quite repetitive. 3 versus 1 was covered in 1 versus 3 up here, and 3 versus 2 was covered here. But essentially it gives you indications of which pairs of communities were different. Okay, and then in that case, that's simply how we use an ANOVA to test for differences, significant differences between treatments. Okay, thank you.